Welcome everyone to this webinar. My name is Trevor Matthews with my good friend James Bailey, and today we're going to be talking about sizing a medium temp CO2 store using MicroPipe line sizing software. A little bit about me and my company. My name is Trevor Matthews. I run a company called Refrigeration Mentor. It's a training organization to help contractors and refrigeration businesses out there to really develop their skills and their talent. And me and James met last year and networked since then and became really good friends. We have a similar type of mindset on helping the industry grow. And he brought this really cool software to me called White Rose software, which incorporated MicroPipe. And I'm really excited today to talk with you and have James talk about this software, because I think it's going to really help a lot of you out who do a lot of design line sizing for naturals or CO2 or even synthetic refrigerants. And I'm hoping today that we get lots of questions. I'm going to have James actually do a live demonstration for you on it, because I think it's very cool. As a technician out of the field, I was not a guy who really thought about line sizing. That was always up to the engineers and designers. But as the years went on, as a technician in the field, line sizing is so important as a technician to troubleshoot a system. And I'm really excited to have James talk about this software. James, go ahead.
Good evening, everybody. Well, evening in the UK, so good morning, good afternoon to some. Thanks for the intro, Trevor. My name's James Bailey. I've worked within the refrigeration industry for almost 20 years, having moved across from the automotive sector. Chartered engineer and specifically of interest really for the audience, fellow of the Institute of Refrigeration here in the UK. I've spent my career working in contracting and consulting. Just over 6 years ago, I started my first company, Wave Refrigeration, which is a consultancy, design, project, technical support consultancy to large end users in the UK. Their customers include Asda, Aldi, Co-op, Sainsbury's, and Distributor Bid Foods. I sold the business and exited last year. I've got strong socialist beliefs, sold the business to the employees, and Wave Refrigeration is now one of only 700 companies in the UK who were owned by its employees via an employee ownership trust. So I've started a new company, Amiga Solutions. Amiga Solutions, it's going to allow me to follow my passions, which I've developed over the year, which is providing training and development opportunities and moving into more of a wider net zero sphere to support the environment as we come away from fossil fuels. But specifically White Rose software. This is a software that I inherited from my long-term mentor, Ian Ramsey. Ian developed White Rose software beginning in the 80s. We're very close, we lived very close by, met up weekly. And 3 years ago, he sadly passed away. So the software and his legacy could have died there and then. Through some good fortune and a lot of hard work from myself, from other people, we managed to get the software back up and running, and it's used by the majority of refrigeration contractors and consultants in the UK. So I'm going to hit everybody with the first slide just now. So a little bit about White Rose software, developed by the late Ian Ramsey. It's been the choice of refrigeration system design in the UK, with a strong emphasis on supermarket system design for 30 years. We have over 30,000 individual refrigeration systems currently operating in the UK alone that have been designed using White Rose software, MicroPipe. So what does MicroPipe do and White Rose? It eliminates the need to size refrigeration systems and lines using charts, which can be a long, laborious activity when you've got many circuits of pipework within a distributed system. So the software itself, it provides line sizes based on user parameters. The 5 major functions calculate suction lines, liquid lines, discharge lines, liquid drain, condenser outlet lines, and relief and vent lines. Also, MicroPipe can also size secondary side pipework, so systems operating on ethylene glycol, propylene glycol, etc. Another key component within MicroPipe is that you can actually add valves, you can add a number of bends to each circuit to actually reflect what the intended installation is. And through adding bends and valves, you're actually accounting for real life line losses. So moving on to the next slide. So what is MicroPipe? What does it look like in its bare flesh? So effectively, here we're looking at, in the middle, the heart of the refrigeration system, the rack within a plant room. To the right-hand side, condenser, or indeed today we're going to be sizing a CO2 system, gas cooler. To the left, just an individual display case. Starting with the display case, the demonstration I'm going to show is mimicked on a small convenience store. So typically a small co-op if we're in the UK, or maybe a 7-Eleven in the States. So effectively, it's a jigsaw. It's sizing the lines in between the display cases and the rack, and then from the rack, the discharge line out to the condenser gas cooler, and then the liquid drain line back to the receiver and back out, and the cycle commences once more as refrigerant enters the display cases. So what it does, it saves time, money, increases productivity. Everyone will see firsthand this evening just how quick it is to size a small store, but it's not just intended for small stores. We can design full, large-scale, super hypermarkets using White Rose software. Indeed, it's just as useful in large industrial settings, in food processing plants, where we might have various areas where being refrigerated. Crucially, as we enter a period of transition, the software has natural refrigerant CO2, ammonia, hydrocarbons, but it also includes synthetic refrigerants, 448A, 449A, higher GWP refrigerants, 407A, 407F. We've got 404A in, R22, which acts as good sense checks. As the software develops, we're entering a period of modernization. We are going to be adding HFO refrigerants to the software as well. A wish of mine, being quite a strong environmentalist, is I'd like to think that the lowest possible GWP refrigerant would be applied, but I'm also quite sensible from the fact that HFOs are going to have a place in the market. So the software is relevant for right here and right now, and will continue to be relevant. So my specific demonstration this evening will focus on CO2 as a direct expansion in a small retail supermarket, which I'd commonly refer to as a convenience store here in the UK. What it doesn't do, we don't do hot gas lines. The reason is it's been predominantly used in the UK. Hot gas defrost isn't commonplace within the UK. Medium temperature applications, they use an off-cycle defrost typically in a supermarket. Low temperature systems use electric heaters within the coil bank within the display case. However, we would welcome your suggestions. As I say, we're entering a period of modernization, so any feedback, anything which you believe would aid you as a designer or as a technician or your business or people within your business, please do let Trevor, let myself know. It'd be much appreciated. So I want to talk a little bit now about terminology. MicroPipe's got its own terminology. So if I speak to a design engineer within the UK who uses MicroPipe, design entries, circuit, terminal, network, next flow path label, oil riser minimum duty. We're all familiar with it, but it might be an unknown terminology to some of the audience this evening. But specifically, design entries, these are user defined. These are what MicroPipe isn't going to tell you, because a system one system to the next, they can have lower evaporating temperatures, higher evaporating temperatures. Indeed, where you set your superheat, that may be defined by your end user, an end user who's got a specification. So you're going to set and define that superheat. What are the maximum and minimum liquid temperatures? Well, I'm assuming for this demonstration, we've got subcooling. So I'm looking at lower liquid temperatures. Enter a condensing temperature, liquid line rise. So what I mean there, from if your plant, and in this demonstration, it's at ground level, it's lifting up to go into the store. So we're looking at sort of 12, 15 feet. And an important consideration, it allows the user to put in maximum line penalties by line type: suction line, liquid line, discharge line. So it allows the user to specify what's important to them. So just going back to specific terminology, a circuit, that's its definition. It's actually just an individual refrigeration line. It's just a piece of pipe in a system. A circuit in MicroPipe is one of two. It's either a terminal or a network. A terminal is effectively a piece of pipework that is attached to a fixture which has a load, a duty. Example, a display case or a cold room evaporator. A network is simply the pipe in between which carries the duties. You'll see as I go through the demonstration what I mean, but what I will say is that anyone interested in obtaining a trial version of the software that will be at no cost, there'll be some design guidance notes to supplement the session this evening that's also being recorded. Next flow path label, you'll see as we build up, this is what makes MicroPipe unique. We can build a big distributed system, just like a river, just like streams that run into rivers, or branches on a tree that run back to the trunk. We number these. So we start at the furthest point away, we work back to the plant, and every time we're entering, MicroPipe needs to know what is my next circuit number. This will become apparent through the session, and there'll also be ongoing support afterwards for anybody interested in the software. Real critical, last point, oil rise, the minimum duty. In CO2, it's a high pressure system anyway, so it's actually not as critical as, say, with lower pressure synthetic refrigerants. But MicroPipe's quite unique. It allows the user, so when we're talking about vertical suction lines with risers, we can accurately size the risers based upon a user parameter of what the minimum duty percentage-wise should be to ensure that oil returns along with that suction gas vapor and back to the compressors. So talking about the aim, so I'm kind of going back on myself, letting you know what I'm going to tell you and then telling you again and tell you what I'm going to tell you. It's going to follow pretty much that vein all the way through. So this session is going to showcase how UK design engineers apply MicroPipe in supermarket refrigeration. In the UK, what we would look to do, a design engineer would typically sketch out an isometric schematic drawing detailing a service route by the designer. The design engineer will then number that schematic, starting from the fixture that's the furthest away in the system and then working back to the plant. Indeed, we'll see this presentation brings to life and helps articulate that specific bullet point. So duties are also added onto the schematic to terminal circuits, with lengths also being added. Generally speaking, white rows, for me, we work in SI units. But some years ago, Ian Ramsey has developed the software so we can calculate using Imperial units of measure. So this evening, instead of talking meters per second, we're going to be talking feet per minute. We're not going to be talking in pressure in bar. We're going to talk about pounds per square inch. We're not going to talk about display cases having a duty in kilowatts. We're going to talk about BTUs to aid the audience, who I suspect are mainly in the whole from in and around North America. Please bear with me, bearing in mind I'm very familiar with SI units, and that conversion back to Imperial can be a little bit taxing at times. Where MicroPipe comes into its own, you may think, okay, I've got two sets of services effectively feeding my fixtures on a shop floor in a sales area in a supermarket. So we concentrate first on running the calculation to size the suction side of the system. And then we follow using the liquid size. The demonstration this evening will show the expedience. Once the suction line calculation has been done, you can transfer all the circuit data from the suction line calculation into the liquid line, enter the liquid line design parameters, and just by running the software, we will be presented with the liquid line sizes within this specific system. So again, mentioned it a few minutes ago, design engine guidance notes to design a refrigeration system using MicroPipe will be provided to anybody interested in obtaining a trial of the software. So we get to the crux of what the demonstration is going to be. Everybody on the call, on the session, you're not going to be able to see this screen once I launch MicroPipe, but I would like to spend just a little bit of time explaining. The top left hand, a crude sketch of a typical very small convenience store. So at the top, we're looking at 4 12-foot display cases multiplexed. Just in front, a small island with 4 display cases. And then at the end, looking at 90 degrees into the store, there's 3 further 12-foot display cases multiplexed. I've simply shown a rack, and to the right of the rack, a gas cooler. So effectively, the key on here is the display cases, suction and liquid lines following the orange line, discharge liquid return line, which is from the rack to the gas cooler. And the small round annotation is just to show a suction line riser and liquid drop. This specific, so looking at the top left here, once we sketch out a schematic, which I hope is understandable by everyone on the call, we've got 25 circuits. So working from circuit number 1, so if we look here at number 1, that's the furthest fixture away from the refrigeration rack. We build up the isometric, we sketch it out, and we number it. So everything follows 1, 2, 3, 4. Looking at this, circuit 1 is a terminal. It flows into circuit 3, it doesn't flow into circuit 2. Circuit 2 flows into circuit 3. Circuit 3 flows into circuit 5. Circuit 4 flows into circuit 5 as well, so on and so forth. For ease of demonstration, I've just assumed everything's got a 12-foot display case within this system, which you may see, you may not, but we're looking at a corresponding 5 kilowatt duty display case, corresponds to around 17,000 British thermal units. Again, this presentation will be made available to everybody. So if you just bear with me, everybody, I'm going to stop the share of this presentation and we're going to go right into the demonstration.
Okay, perfect. We can see it now, James.
Perfect. Thank you, Trevor. So when launching MicroPipe as a program, this is the home screen. This is what you will see. Effectively, you can look at the license agreement. That doesn't change. You can choose not to accept it or choose to accept. So here we are. It jumps here to, this is the first page we see. You will always work within the block within the middle of the screen. As you can see at the moment, we're in degree C, we're talking about Kelvin, we're talking SI units. So the tabs from the design entries, you've got your suction line, your liquid line, discharge. You've also got pumped. We're not talking about a pump system, but we are going to run a demonstration on pumped CO2, glycol lines, etc. going forward. So from here, what we look to do is we can set, at the moment, it's defaulted to SI. I want to convert everything. I want to convert it all to Imperial. I'm going to apply settings and close. So as you can see, what's the impact is, so everything now is shown in degrees Fahrenheit, Imperial unit of measure as opposed to SI. Coming up here at the top, I've selected refrigerant and tube. As you can see, we've selected here, it's defaulted to R404A. We're doing this demonstration in CO2, and I'm actually going to select K65, which is those you're probably aware, high pressure rated copper piping system. It's got a small iron content to allow the system, to allow the pipework to operate under higher pressure. Apply settings and close. So going to the suction tab, you'll be able to see at the bottom the three boxes. We've got network 1 of 1. At this moment in time, it's saying there's 1 circuit. This system I'm going to demonstrate is 25 circuits. Rather than me talking now, if you don't mind everybody, I'm going to hand over to Trevor, who's going to be doing a little bit of talking, but I'm going to run through this calculation and you'll hear from me again, probably 10-15 minutes time.
Awesome. Thanks, James. Yeah, so you can watch the screen while James is plugging in the information. And as for a lot of you, I know there's quite a few designers and engineers. There's some technicians on here. There's a variety of different people who may or may not design systems. Personally, I've never engineered or designed a system like this. I've done line sizing before. I've actually done it using a refrigeration handbook. It was built by well, this one that I use was created by DuPont, and I started using it back in the early 2000s, that line sizing guide. And Garth Dennison, I believe, is the gentleman who designed that one, the one here in Canada or North America. And I used it before as a technician, but I never really thought about line sizing for troubleshooting. You know, I always thought, okay, that was done by the engineers or the OEM or the design system. Everything should be good. Over the years, I started to realize how important as a technician it is to know proper line sizing, the proper velocity to have in a system to make sure that oil is coming back, make sure that the system is sloped correctly. And that, I know that has nothing to do with line sizing, but proper traps, proper risers. When we start to get into new systems that have capacity control, like unloaders, digitals, variable speeds, it's so important to understand this line sizing. And as engineers and designers that are creating these magnificent designs, you need to understand that. And as you can see, James is still continuing to go through here. He's at circuit 11 already. And as you know, a lot of you that are designers out there, there is a little bit of pre-work that you need to do. You know, you need to maybe draw a little schematic when you're going to a building where there's nothing. You're the first one there on site and it's just a box, and where do I start? So it's important that, you know, you draw this stuff down. And I've been learning more and more about designing. I got a question here from Dimitrios. Thanks. In a CO2 booster system, we usually have a medium temp and a low temp load. The liquid line is the same for both, but we have different suction lines. Can we do it on the same software? Well, that's the question I'm going to have to ask. Yes, you can. You definitely can. So look at James multitasking. I love this. As an engineer and a designer, it's very important to be able to confidently complete a project on a certain amount of time. You know, and if you can complete a design instead of taking a full day, because me and James had some really good conversation because he's done charting, and I'd love to see down in the chat who still uses charts, you know what I mean, and how long it takes, because I've been talking to more and more people that contractors, especially who have engineers servicing, doing their line sizing, and where they've ran into problems before where there was maybe a mistake or not. So that contractor now sometimes reviews the line sizing. And he says sometimes it could take up to a day to do a store. if you can get a software that potentially can do that in half the time, I think that there's a lot of value for you as an engineer out there, or even as a technician or a contractor out there where you are getting these services just to verify that line sizing. And I know me and James talked many times about how technicians can use it in the field, because one of the hardest things in a system, as you guys know, as designers, is there becomes an oil issue. And it could be from many things. It could be from the slope, could be from the sizing. Maybe they used the wrong pipe. Maybe they didn't pull the plugs out of the pipe. Who knows? There could be a lot of things. But as a troubleshooting tool, you can go back and check through a software like this to figure that out. Will you do this every time? No, you definitely would not. But when you run into those situations where there is a difficult problem, you can verify what that line sizing could be. Could you do it on a chart? For sure. You definitely could do it as well. We are calculating for a branch piping or a home run piping. This would be a home run piping system that James is doing, I believe. And can we use in industrial refrigeration? Yes. Yes, you definitely can use this in industrial refrigeration. Actually, there's quite a few, me and James talked about it, quite a few plants that have been done. Is the software available to download? Okay, I got a question there directly to me. I'm going to have a question out later. I'm going to pop a poll up after round end. If anyone's looking for the software who sticks around in that question, if you would like to receive a copy, through that poll, I will be emailing each one of you individually. And so,
hey Trevor, just a quick coming back to everybody. So I've now sized the suction line side of the pipework. So going from the furthest fixture
already?
Absolutely.
What? So that was pretty fast. Like, come on now.
We're talking 1/2 inch, and I'm just scrolling through here so you can see everything's changing. So you can see the velocities, you can see the maximum penalty. So as we go.
Can we just go back to circuit one and kind of explain what you did? So the process, because you did it. So the process is that you did a little drawing. We showed them the drawing of all the different terminals, and then the network piping. And then if you went back to circuit one, just go back to circuit one. So this is just the suction, right?
This is just the suction. So circuit one is a terminal. It's connected to a display case and it's flowing. Its next flow path label is 3. So looking at this, so circuit label 2 is also a terminal. It feeds into network 3.
And so if everyone remembers that those display cases, those first 4 display cases that were 17,000 BTUs, 1, 2, 3, and 4, I think, or 3, they all went up to that next flow path which was 3, and then 3 connected into 5. So if you look at the duty, it was 17,000 BTUs on circuit 1, and then he put circuit. If you go back to one more time, James.
Cool.
Just so he put 12-foot length, 6 radius, and then that was the circuit 1 from that terminal or that termination, which was that case, and then it flowed into 3. And then he did that consistently throughout the whole chain from 25 all the way back. Is that correct, James?
That's correct.
Okay.
So just running through, so obviously the circuit number 3, which is network, you can see there, it's carrying a duty of 34,000 BTUs at maximum design conditions. That's quite important to mention as well. MicroPipe assumes that once you put your design entries in, it's working at worst case scenario, i.e. middle of summer on a real hot summer's day. So the lines that are sized using MicroPipe, you know they're going to be good in low ambient, they're going to be good in high ambient conditions. So just moving just quickly through, so you can see, if I can just take everyone's attention, where we're reading suction pipe system analysis, pipe size. Down there, we're seeing in these columns things that are changing. So we've got the pipe size, oil return, average velocities, the penalty that's been absorbed, its actual saturation temperature. So ultimately, we've got some small pipe work, then we're getting into a little bit bigger at 3/4. It's CO2 again. We're not going to see any horrendously sized 3 1/8 or 4 1/8 pipe work within this system. But as we can see, when we go, so effectively, you'll notice that there were two risers, which circuits numbers 14 and 23. So we actually have an icon to select a riser. We can select a single riser or a double riser. Single risers, obviously, where practical, where possible, due to the time it takes to install a double riser. I effectively, your oil return, if you've only got one fixture, so imagine in a cold room, you've got your cold room, you've got your vertical suction line, that you're wanting to return 100% of the duty. If you've got two fixtures connected to one riser, you're wanting to return 50% of the duty at any time. The lowest I generally go is 3 or more fixtures, which is exactly what we've got in this instance. I select my oil riser minimum duty at 33%. What this is actually telling me is that this riser would go down to 29% based upon the software selecting a 7/8 pipework for this specific riser and circuit. So as we go through, I'm going to take you right to the end. So this is effectively circuit number 25. This is the circuit which would connect into the suction header of the rack. So we've got a nice velocity of 1400 feet per minute. So we're not too high there. So we're not going to cause any disruption when we're trying to get, when we're metering the refrigerant into the compressors. And we're looking at a size of 1.1/8". Now, what I'm going to do here is I'm just going to simply...
Just before you do that, James, I got a couple questions for you. So just hold up. So some great questions here. Matthew asked, can you edit the loop after the initial design?
Yes, you can. Yes. And that's where you need to be familiar with the software. So I don't know if you can see the cursor of my mouse. So here, so obviously I built it up by hitting +10 twice and then the individual circuits 5 times to get a 25 circuit network. Effectively, if you've got a customer and you've done a design and they've decided to add some more cabinets or take them away, you'd need to go back to your sketch for sure and do some little bit of renumbering, but you can add circuits into a circuit. So I will cover that within the design guidance notes, because that for me, I haven't worked as per se a design engineer day in, day out for quite some years now, but that used to be a real, no matter using the software or not, it's still a frustration when a customer changes their mind and the layout slightly changed, or they've added more cabinets or taken some away. But once you've done the calculation, you can open it, you'll just save it as you would any document. You'd add revision A or version 1.1. And so you're still left with your original design, but you've got your brand new calculation as well.
Awesome. Another question here. Is there a limitation value of the pressure drop in minimum velocity?
No, there's not. No.
Okay.
No. What it does, so for me, White Rose software, so when I've trained any or helped the training of any engineer, I haven't let them, or a trainee, I haven't let them near the software. I need them to understand thermodynamics to start with. The critical part is understanding thermodynamics and knowing and entering the design entries, because the software is going to work within the limitation of the design entries. And actually, I would always go through each circuit and check the velocities, check the losses, and just to make sure that I'm happy with the outputs of the calculation from my base knowledge. So it does have a requirement for a user. We've all got to start from somewhere. It doesn't need somebody to be super experienced, but from my experience using the software, either as a trainee or as a more experienced designer, a more experienced designer has to be there for a younger trainee or an apprentice. But conversely, that apprentice trainee, they need to be able to put their hands up and ask those questions, which, as we know, sometimes can be difficult.
Yeah, no, that's perfect. There's quite a few more questions. So just keep going, James, what you were doing. So
yeah, no problem.
And then we'll ask some more questions.
All I'm doing here is I'm going to save this, simply call it suction. So it allows you to put project in, reference, engineer. So I'm going to save this. I'm just going to call it suction calculation. And everybody, that's saved now. Where MicroPipe really comes into its own is, what about the liquid line? So up at the top here, we have a tab called Data Transfer. Transfer network data from suction to liquid. Well, I've got no liquid data, so it doesn't matter. Yeah, I want to continue. So clicking on liquid, you can see the base information's there. We've got 1 of 25. The analysis is empty at the moment. So going into the design entries tab. And by the way, everybody, as I say, you know, I'm not being specific here. I'm not going to tell a designer what parameters they should be using. Far from it. I'm just using this as an example session for everybody. So hitting liquid there. So this little arrow here, which for those who are old enough, looks like a play button on an old cassette player. There we go. So we've calculated the liquid line. So we don't have to do anything but hit the run button and go through each individual circuit, just as we did previously. So you can see everything's changing. So I'm quite happy on a liquid line. I'd like to keep everything under sort of 1.5 meters per second, or in this instance, 300 feet per minute is sort of my target. So I'm just going to run through here. I'm happy with what I'm seeing so far.
Oh, and that's super quick, right? So you do that one main suction line, and then now you can start getting all this other information pulled together. Wow.
So another great thing so we're all different as designers. So somebody on the call might say, well, I don't actually want the main liquid line to be 3/4 of an inch with a velocity of 255. I want it to have a lower velocity. So hitting the padlock here, you can go up or down. So select 7/8. I'm going to fix that. Run the calculation again. So as you can see, it's dropped that velocity. So it allows the designer to override any output that the software provides. So it's quite good. The output's not saying, you know, it's going to give you a system that's going to work, but a design engineer might think and go through for whatever reason. They might want to have a lower penalty. They might want to have a little bit of consistency. As we all know, installation technicians putting in pipework in the middle of the night, if you're building up a big header system, once we've got that armor load insulation around the pipes, you don't actually know necessarily what size diameter. So I'd always look at high level pipework and try to have some continuity. So it's a design friendly system for the installation technicians. I'm going to do very much the same here. I'm going to save the system. See, this is just liquid. Okay. Just something just to point everybody in the direction. So the overall, of the 11 cabinets, of the 11 fixtures that are in this system, it accounts to 187,000 BTUs. Just important, just now I'm going to go to the discharge line. So from the main discharge header, from the rack, that line going to the gas cooler in this instance, or condenser. So again, before you do anything, your design entries is always going to be empty. So I'm going to just crash through some example numbers here. This is a terminal, and that's why I just referenced before. So its duty is 187,000. 60 feet in, put some bends there. And as you can see, you'll have seen me put in valves before. Sorry, I'm going to select just a regular shutoff valve. So here we go again, press the play button. And that's what it's giving us. It's saying, right, my discharge line is going to be 1 3/8, And based upon the maximum duty of 187,000 BTUs, we're going to have a velocity of 2,500 feet per minute. I'm certainly good with that. You know, it's a good velocity. But what about the drain line? So what about the outlet from the other side? It's quite simple. So we've got this annotation here, which is your liquid drain. So again, it's actually calling for, well, what's its duty? 187,000, put in 60 feet. You know, we'll just a number of bends, ball valve. And what we've got here, we can auto select. So it's selected 1 3/8. If you felt actually that's a big piece of pipe work, you know, I can increase the velocity. Well, sure, you know, go to 3/4 and you've got 287. So you can either auto select and accept, or as user defined, you can accept that as well. Where you've got multi inlets into a condenser and outlets, you can do similar. You can sketch up an isometric and have different circuits, but for ease of expedience here, generally on a small system, we'd have one discharge line fed into a condenser or gas cooler and the outlet. So I'm going to accept that. And again, simply enter project references, discharge and drain. There we've got those circuits all sized. So I hope everybody can see that with expedience. Of course, yes, I'm familiar. I've got lots of experience with the software, but just how quick it can be to size refrigeration line sizes in a whole system. Anybody interested in the demo, what I will do along with Trevor is the calculations that I've worked on and saved, they'll be issued to you as well, so you can play around with my calculation, you know, so you've got a base to work from. But effectively, like any piece of software, you know, if you want to start new, hit the new start new project, it'll take everything back, which I certainly don't mind doing now. I've saved my work. Here it's going to say it's all the system data is going to be deleted. Well, that's cool because I've already saved the software. I've already saved the calculation. And what we go back is we default back to 1 of 1, ready for you to build your number of networks up. So you can go up to, you know, that's probably the largest system, 140 circuits within a system that anybody would ever design. So, and again, design entry, you will populate those dependent upon what system. You know, I've selected evaporating temperature of 23F, which corresponds to -5 centigrade in the UK. But of course, we've set this demo up for the North American market and those who work in SI units effectively. So I guess from my perspective, that's kind of at the end of the demo.
Awesome.
Over to you, Trevor, and then questions, I guess.
Yeah, so I do got a bunch of questions. Thank you so much for the questions here. So we got Damon asked, what is the minimum velocity criteria for a suction line?
Damon, there isn't really one. I mean, from my perspective, I'm going to start talking here in SI units, and apologies. So I follow, so anybody from the UK will probably follow the British Refrigeration Association guidelines, which would state maximum, you know, the intended maximum velocity in a horizontal suction line be 10 meters per second, and in a vertical 15 meters per second. I'm not too precious about those through experience, but so from a minimum perspective, you can't really have a minimum, but ultimately as well, if you're running through a calculation and you've got a terminal and you only need a 5/8 suction line, you know, ultimately the software is going to tell you if you try to force a selection of 1 1/8, for example, you're going to end up with a real low velocity. That's going to flag up as a concern with oil return. So you're going to get a warning from the software. So if you do something that the software recognizes intrinsically going to inhibit performance and operation, it's going to tell you there's a problem.
Yeah. Here in North
liquid
America,
lines, Trevor, quite important. Liquid lines. I try to target a maximum velocity, certainly at the fixtures of 1 meter per second, because ultimately, once you hit an AKV, you know, assuming it's electronic expansion valve or cut down for AKV, you don't want to be above 1 meter per second. You could suffer from liquid hammer.
yeah.
But the software knows that, you know, it's not going to undersize a liquid line to give it a high velocity.
Yeah. So for here, I know in all the books I've read, it's for suctions is around 1,500 feet per second and 750 feet per second, depending on vertical and horizontal. And for liquid is 300, you know, just like you said, liquid hammering. Okay, next question we got here from Matthew. What are the set limits for velocity in the suction horizontal riser? Does liquid line size based on velocity or pressure drop? That's a similar question.
Yeah, I think just to differentiate, I think the first question, part of the question was answered, but specifically liquid lines, yes, its overriding feature is working on the penalty that's input by the designer. But then obviously you go back as a designer to have a look at the velocities. And if you're unhappy with the velocity that the software is given, it gives you the opportunity to lock that particular circuit or a series of circuits within the system at a user prescribed diameter of pipework, as opposed to the one that's been auto-selected.
Awesome. Another great question here from Dimitrios. Does the software give you a summary of materials needed, like pipe dimensions, lengths, tees, and bends, etc.?
It gives you the lengths. It gives you the total length by pipe size. Within the software, bearing in mind, you know, I'm now custodian of the software, and we're going to be involved in a rewrite. It will give fittings. It is within the code somewhere. It was never activated by Ian. He was asked to develop that by an end user in the UK who will remain nameless. Ian didn't actually announce, but he wanted to be paid for it. And obviously there was no money available to pay. So that setting, it needs a 0 changing to a 1. And that
awesome. Great news.
Will appear.
Next question. According to design entries, the temperature loss is the main criteria of calculation instead of pressure drop or velocity.
It's a penalty. It's your total penalty. So if we go to design entries, it's going to be governed by what you've stated as your maximum permitted penalty. So you might choose, actually, James, you've been too generous there. I want to call it 1 Fahrenheit. That's what's going to govern the selection of the pipework. The velocities and losses you will see on each individual circuit, and that's what MicroPipe allows the designer to do. If a designer is not agreeable with what the software is given, which will happen from time to time, I don't take what the software provides as an answer as gospel, because experience can tell me otherwise. I may make some changes. So you increase, decrease your line size to ultimately, as the engineer, the design engineer who's looking after this system is happy with.
Awesome. I'm going to shoot out a quick poll here. Once again, I'm going to continue to go through the question because I have quite a few people that say they need to jump off for another meeting. But after seeing the presentation today, would you be interested in a 1-month free trial and demo of MicroPipe software? So just say yes or no. Anyone who says yes, I will be emailing you personally. And we'll get back to some more questions. Okay, James, here's another question. Besides adding in fittings, is there a way to add an additional safety factor to account for any additional bends in the pipe in the field that may not have been accounted for in the initial design?
What you would hope for there is at site conditions that the installation technicians will come back. So if there's a change, and this does happen for sure, inform the designer so he can change or she can change their schematic to account and then run through the software again. Generally, what I try to do is I use quite tight penalties in the UK. So generally, we look at a 2 Kelvin line loss on a suction line from outlet of evaporator to inlet of the compressor rack. I generally design on 1 Kelvin effectively, because I know that it's going to be a little, it's if we get to the stage of additional bends being required, I know that I've generously designed that refrigeration system. There is an argument. I know some designers who don't account for bends. They don't put valves in. They just reduce the line penalty. And through their experience, I don't do that, because the software gives you the opportunity to put the bends in, to put the valves in. And as you can see, it becomes like a subconscious activity once you're familiar and you've been using the software for quite a long time.
Okay, well, lots more questions coming in. I'm loving this. I think it is important to show the report of the calculation. They have many information. So there is a report you can get, right, James?
Yes, there is. Yeah, absolutely. So the report actually, Trevor, you would have to you'd print to PDF, and you'd get a PDF output on a page of A4. Excellent.
Another one. Sorry, I missed the first 20 minutes. Does the software calculate cascade for subcritical design? Yes.
Yes, it can do. Yeah.
Are there limits to sizing of system design, large systems and cascades? So is there a limitation in how big the system you can size?
And there's not, that's governed by the largest pipework, which is 6-inch within MicroPipe.
Okay, so 6-inch. So that would be the size.
So
okay.
That's quite a size. That's on a distributed system, Trevor. We can go larger if we're talking a cascade. If we're actually pumping a fluid, if it's a secondary systems, whether it be CO2 or a glycol.
Okay, excellent. Last question that we have here. Is there any plan to develop visual interface?
Yes.
Yes. Yeah. So
yes.
That's in the works right now, which is very exciting for me. If you have ideas and things that you want to add to it and something that will make your life easier as a designer and engineer, you would like to see, please reach out to me or James so we can see if we can incorporate that into this software. We only have 3 minutes left. Dimitri asked, could you show us on the demo how to run the medium and low temp load on one liquid line? I don't know if we have enough time to do that.
I think what Dimitri's asking for, that's a really good question. You know, we're seeing lots of booster type systems in CO2 where we've got a single liquid line. What I'd like to extend out is a specific demo of how to do that.
Awesome.
So
awesome.
Yeah, absolutely. Bearing in mind, Dimitri, we've got an hour here, and I wanted to try, as long with Trevor, to get as much into the session as we could.
Okay, I don't see any more questions there. We got 2 minutes left. I want to thank everyone for taking their time today. I really appreciate it. I hope there was a little bit of value in here that you got to see. And if there's other things you want to see, I know there's people have been asking me already, can you show us how to do relief lines? Can you show us how to do what Dimitri said, liquid and the low temp, liquid line for medium low temp? These are things that we'd love to show you. And reach out to us if you have any more questions. Once again, thank you so much. James, thank you so much.
No, I just want to thank you, Trevor, but thank you to everybody. People have taken a lot of time out of the day, whether or not around lunchtime, afternoon, or even the evening, wherever everybody is. I just want to say a massive thank you to everybody, and I hope that it's been of interest and value.
Awesome. Thank you so much, everyone, and have a great day.
Thanks all. Bye-bye.